Astronomers first detected the anomaly in early 2025, a faint streak across telescope images that defied initial classification. Designated C/2025 A6 Lemon, this object was uncovered during routine surveys by the Mount Lemmon Observatory, its brightness gradually intensifying as it plunged inward from the outer solar system. Initial calculations revealed a trajectory unlike typical comets, with an orbital period stretching over a millennium, suggesting it had been lurking in the frigid Oort cloud for centuries. As data accumulated, discrepancies emerged. Erratic brightness fluctuations hinted at volatile outgassing, while spectral analysis indicated a composition rich in primordial ices and dust, remnants from the solar system's formation. Scientists scrambled to model its path, noting its unusual inclination that brought it perilously close to Earth's orbit. Yet, early observations raised alarms. Its nucleus appeared larger than anticipated, potentially spanning several kilometers, evoking comparisons to historic impactors. The chapter delves into the painstaking process of confirmation, involving global observatories like Hubble and ground-based arrays, where initial dismissals as a mundane comet gave way to growing intrigue over its anomalous behavior. As the object accelerated, whispers of interstellar origins surfaced, though evidence pointed to a homegrown wanderer with hidden perils. Even if these fluctuations signal something more sinister than mere ice sublimation, with its discovery secured, attention turned to the object's unforgiving path through the inner solar system. Orbital mechanics painted a chilling picture, originating from the distant Oort cloud, perturbed perhaps by a long-forgotten gravitational nudge. C/2025 A6 Lemon was hurtling sunward at speeds exceeding 30 kilometers per second. Simulations projected its closest Earth approach on October 21, 2025, at a distance of approximately 0.6 astronomical units, close enough for potential naked-eye visibility, yet distant enough to evade immediate catastrophe. However, uncertainties plagued the models. Minor perturbations from Jupiter's gravity could alter its course subtly, raising specters of fragmented debris trails intersecting Earth's atmosphere. Astronomers tracked its progress meticulously, noting how solar radiation pressure warped its coma, creating an ethereal tail that stretched millions core on the verge of disintegration. Probing deeper, spectroscopic studies revealed the object's enigmatic makeup, a frozen archive of cosmic history laced with potential threats. Ultraviolet and infrared data exposed a nucleus composed of water ice, carbon dioxide, and exotic organics, materials unchanged since the dawn of the solar system. Yet, anomalies abounded. Elevated levels of heavy isotopes suggested formation in a distant, radiation-battered environment, while dust particles analyzed via remote sensing hinted at metallic inclusions uncommon in typical comets. As solar heat intensified, outgassing jets erupted unpredictably, altering its rotation and brightness in ways that confounded models. Scientists hypothesized volatile pockets within, capable of explosive releases, drawing parallels to the disintegration of comet Shoemaker-Levy 9 upon Jupiter. The chapter explores laboratory simulations replicating these conditions, where researchers recreated cometary ices to test stability, uncovering risks of fragment ejections that could spawn meteor showers or worse. International teams, including those from the European Space Agency, debated its classification. Is it a pristine relic or a disrupted body bearing scars from ancient collisions? As visibility improved, amateur observations flooded in, corroborating professional data but introducing new puzzles, like faint radio emissions detected sporadically. What if these emissions are not natural, but harbingers of an undiscovered phenomenon? As the object drew nearer, the specter of collision risks escalated, transforming abstract data into tangible concerns. Though its primary trajectory posed no direct hit, probabilistic models accounted for uncertainties. A 1 in 10,000 chance of atmospheric interaction from shed fragments, potentially triggering fireballs or regional disruptions. Historical precedents, such as the Chelyabinsk meteor, illustrated the dangers of even small pieces, with shock waves capable of shattering windows across vast areas. The chapter scrutinizes defense strategies, from NASA's Planetary Defense Coordination Office simulations to hypothetical deflection scenarios using kinetic impactors. Scientists monitored for signs of breakup, noting how solar wind eroded its surface, possibly liberating hazardous dust clouds that could interfere with dead comet, reactivated by gravitational tugs, its dormancy masking volatile reserves that now threatened instability. Others explored astrobiological angles. Could its organics harbor prebiotic molecules, seeds of life ejected from ancient worlds? Investigative teams analyzed light curves for rotational anomalies, suggesting a tumbling motion induced by asymmetric outgassing, while computer models simulated its Oort cloud exile, disrupted perhaps by a passing star millennia ago. The chapter details cutting-edge research, including proposals for flyby missions akin to Rosetta, though time constraints rendered them impossible. Controversies arose over data interpretations. Discrepancies in mass estimates fueled speculation of a denser, rocky core beneath the ice. Collaborative forums, from virtual conferences to real-time data sharing, highlighted humanity's unified front against the unknown. Yet gaps persisted. Why did its brightness surge unexpectedly, defying predictions? As telescopes worldwide focused, new observations hinted at companion objects in its wake, possibly mini-moons or ejected boulders. If these companions exist, what gravitational chaos might they unleash upon our system? With the closest approach imminent, the object's legacy unfolds as a tapestry of resolved facts and persistent riddles. Post-passage projections indicate a slingshot around the sun, flinging it back to the outer realms, but not without leaving traces, potential meteor streams intersecting Earth's orbit in future years. Scientists anticipate a wealth of data from its transit, refining models of cometary evolution and solar system stability. Yet, core mysteries endure. Its precise origins in the Oort cloud remain speculative, influenced by uncharted stellar encounters, while anomalous behaviors during peak activity suggest undiscovered physical processes. The chapter reflects on broader implications, from enhancing planetary defense protocols to re-evaluating the frequency of such visitors. As it fades from view, questions about its influence on Earth's environment linger, including possible atmospheric injections of exotic materials. Ultimately, this encounter underscores the fragility of our cosmic isolation, prompting renewed vigilance against the void's hidden threats. But as it retreats, what other monsters might it herald from the darkness beyond?